Yeah, good evening, class 9. Good evening, online students.
Good evening, ma'am.
Yeah, good evening. I've shared my screen, children. Is it visible? Right now, it's a blank screen. Please acknowledge online students. Yeah.
Yes, ma'am.
All right, children. So today's topic is linear equations and two variables, x and y. Yeah. Krishna Priyan, come forward. Will not waste time. Come fast. Now you can come here. Yeah. Sit one behind the other. The three boys. Choose your places. Sit one behind the other. Come forwards. You're staying there. Yeah, come forward. Come forward. Yeah. Yeah, children, write down along with me. Yeah, you can leave. Take down the two questions, finish it at home.
We cannot.
You can go down then?
Yes, ma'am.
Okay. Yeah.
If you're free, ma'am, you can call and tell her that when she came, you can call.
No, you should call from that side.
Ah,
You can call from there. Yeah, you can call. You don't tell me anything. That is everybody's phone. You just lift it and talk. Taking the two questions, Dhanvin? You don't want to try it now, so close your book, pack your bag, and if somebody's come to take you, you can leave. Yeah, otherwise wait for them to come. And if you've taken the questions, yeah, take the questions and you can leave. Done writing this, children? Finished your class? Finished writing this one? Online students?
Yes, ma'am.
Yes, ma'am.
Okay. So you can see below the we have taken a linear equation in one variable x, right? 3x plus 11 is equal to 0 is a linear equation in one variable x. When you solve it, what is the value for x? X is equal to minus 11 by 3, correct? X is equal to minus 11 by 3. So we say that minus 11 by 3 is a solution or a root of this linear equation. The linear equation is 3x plus 11 is the the linear equation is 3x plus 11 is equal to 0. Okay. How many variables are there? Only one variable x, correct? 3x plus 11 is equal to 0 is a linear equation in one variable x. Why do we say it's a linear equation? Because the power of x is 1. What is the power of the variable x? 1. So that means linear. If the power of x is 2, quadratic. If the power of x is 3, cubic, meaning the highest power of x. You know that. Okay. So here there's only one variable x and its power is 1. So linear. Now, if we say 3x plus 11, that is a linear expression. If you say 3x plus 11, that's a linear expression in one variable x. When you say 3x plus 11 is equal to 0, then that is a linear equation in one variable x. When you find the equal to sign, it's an equation. If you find the equal to sign, it's an equation, correct? Simply 3x plus 11 is a linear expression. Equal to 0, linear equation. Linear because the power of x is 1 or the highest power of x is 1. So linear. Now this linear equation in one variable x has only one solution. And how do you find the solution or the root? By solving it. Now on solving, we find x is equal to minus 11 by 3. Now this minus 11 by 3 is the only solution or the only root of this equation. Why do we say so? Because in the equation, okay, why do we say that minus 11 by 3 is a solution or a root? Now take up the LHS. What is the LHS? 3x plus 11. What is the root of the solution we got? Minus 11 by 3. So 3 into, use that value, minus 11 by 3 plus 11. So 3 and 3 gets cancelled. Minus 11 plus 11 is equal to 0. Is equal to 0, which is the RHS. Which is the RHS 0. Now, minus 11 by 3 is the only value of x that can satisfy this equation. You give any other value for x, the equation will not be satisfied. You give any other value for x, the equation will not be satisfied. When x is equal to minus 11 by 3, the equation is satisfied, meaning in the left hand side, in place of x, when you use minus 11 by 3 and work the left hand side, you will get 0, which is the RHS. Now, if you give a different value for x, you will get some other value, but not 0. So that's why we say minus 11 by 3 is the only solution for this equation. For this equation, that's the only solution, minus 11 by 3, which is why we say a linear equation in one variable x a linear equation, one linear equation in one variable x has only one solution. And the other thing we understood is this solution is represented by a point on the number line. That's what I wrote. This point, the solution is represented by a point on the number line, correct? Okay, so how do you represent the solution? Minus 11 by 3. Okay, so representing, you write it one below the other. Now listen to me. Representing, okay, the solution, representing the solution minus 11 by 3 on a number line. On a number line. All right, children. So 0 by 3, 1 by 3, 2 by 3, 3 by 3, 3 by 3 is 1. 3 by 3 is 1. Now we don't want the positive side of the number line. We want the negative side of the number line because we have to represent minus 11 by 3. So, and it's by 3, no? So we're going to say minus 1 by 3, minus 2 by 3, minus 3 by 3. This is minus 1. Then continue. Minus 4 by 3, minus 5 by 3, minus 6 by 3, which is 2, minus 2. Minus 7 by 3, minus 8 by 3, minus 9 by 3, which is minus 3. Yeah. All right. Then minus 10 by 3, minus 11 by 3, minus 12 by 3. Minus 12 by 3 is minus 4. And this is minus 11 by 3. This one. This one is x is equal to minus 11 by 3. We got the value of x, no? X is equal to minus 11 by 3. We have represented that on the number line. X is equal to minus 11 by 3. Now we started with, meaning we've written with denominator 3 because the solution has denominator 3. If the solution has denominator 7, then we'll write 0 by 7, 1 by 7, 2 by 7, 3 by 7, 4 by 7. Then 7 by 7 will be 1. Then 7 by 7 will be 1. 14 by 7 will be 2. 21 by 7 will be 3. And on the side, minus 7 by 7 is minus 1. Minus 14 by 7 is minus 2. Minus 21 by 7 is minus 3 and so on. So you should keep writing till you find the solution. So what is that we have on the slide? Ax plus b. Ax plus b is a standard form. Ax plus b is a standard form of a linear expression in one variable x. X is the variable. What about a and b? They're real numbers. A and b are real numbers, but a should not be 0. A should not be 0. Why? Because if the coefficient of x is 0, then it will become 0x, right? 0x means x is not there. Then how can it be a linear equation in x? X is very important there. In ax plus b, x is very important. Because of the presence of x only, it is linear. The power of x is 1. That's why it's linear. And in one variable x. Now, supposing this a is 0, then it will become 0x. Say like 0x plus 7. 0x means 0 plus 7. So it is only 7. And 7 is not a linear expression. Yes or no? So that x should remain. Then when will x disappear? If a is 0. If a is 0, then x will disappear. Ax, if it is 0x, it is 0 then. Then x is not there. So a should not be 0. It can be anything other than 0. B can be any real number. B can be any real number. B can be any real number. A also can be any real number, but not 0. Understand? Then when you equate it to 0, ax plus b is equal to 0. When you equate it to 0, it's called a linear equation. Linear expression becomes a linear equation. Linear expression becomes a linear equation when you put that equal to sign, equated to 0. So ax plus b is equal to 0 is a standard form of a linear equation in one variable x, again where a and b are real numbers, but a should not be equal to 0. All right. Then further, it has only one solution. A linear equation in one variable x has only one solution. Correct? It has only one solution because when you solve, we took an example and when we solved it, we got x is equal to minus 11 by 3. And you understand why that's the only solution, because that's the only value of x which can satisfy the equation. And you also saw how to represent the solution on a number line. That one solution can be represented by a point on the number line. So what you've seen so far is ax plus b, which is the standard form of a linear expression. Ax plus b is equal to 0, standard form of a linear equation. A and b real numbers. A should not be 0. Then when you solve the linear equation, you get some value for x. That's the only solution. That is the only solution. Because that's the only value of x which will satisfy the equation. And this solution is represented by a point on the number line. And how to represent on the number line, we just saw. Even if you have like, root 2x minus 3 is equal to 0. So you get x is equal, root 2x is equal to 3, x is equal to 3 by root 2. Now you will say, if I get a question like this, how will I represent this on the number line? Such questions will not be given to you, but it is possible to represent. It is possible to represent, but we will not be doing it. We will not be asked or given this situation. Because we know that every real number has a unique position on the number line. Every real value has a unique position on the number line. Every number you get in your mind can be represented by a point on the number line. But we have learned to represent only a few things. We know how to represent integers, fractions like this, or maybe root 2, root 3, root 5. Specific things we know, but everything we don't know to represent. So that situation will not be given to you. If you have a question like this, if I get x is equal to 3 by root 2 and they ask me to represent this on the number line, how will I do it? This is possible, but will not be asked for you. Is the answer. You get that? Why? Because 3 by root 2 is a real value. It's an irrational number. It's an irrational number. It's a real number. It has a unique position on the number line. All right? Yeah, write down. Write down, children. So now when you treat this linear equation in one variable x as a linear equation in two variables x and y. So you can see that 3x plus 0y plus 11 is equal to 0. Then its solution, then it will have infinitely many solutions, and its representation, its geometric representation will not be a point on the number line. It is represented by a straight line in the Cartesian plane. One second. Yeah. Yeah, sorry, children. Yeah, so what I was telling is 3x plus 11 is equal to 0. What is this? Linear equation in how many variables? How many solutions it will have? Only one solution. What is the solution? And how is this solution represented? By a point on the number line. By a point on the number line. Correct? By a point on the number line. Okay. Now what are we doing? We are treating the same equation as a linear equation in two variables x and y. We are treating the same equation as a linear equation in two variables x and y. So we are writing 0y. What is 0y? 0 only. You're not changing the equation. 0y is 0. Now, when you represent this linear equation in one variable x as an equation in two variables x and y, then it will have infinitely many solutions. And so its solution will change, its representation also will change. In the first case, one solution, geometric representation, point on the number line. In this case, the solution will change. It will have infinitely many solutions. So if the solution changes, how will it have infinitely many solutions? Only if it's a number, if it's a line, right? A line has infinitely many points on it. So since it has infinitely many solutions, its representation, geometric representation will be a straight line in the Cartesian plane. I'll just include that. Children. I'll just erase this and I'm going to write this again. I didn't mention about the solution. So in this case, it has infinitely many solutions. Infinitely many solutions. Its geometric representation. Its geometric representation is a straight line. Straight line in the Cartesian plane. So when you treat it as a linear equation in two variables x and y, it will have infinitely many solutions. And its geometric representation will be a straight line in the Cartesian plane. All right? Okay. Now we'll see why it has infinitely many solutions. I have to tell you that, right? Why it has infinitely many solutions. Because whatever value you give for y, the value of x will always be minus 11 by 3. See here, whatever value you give for y, because y is 0, y, no? So whatever value you give for y, supposing you say y is 1 or y is 2, y is 3, y is 4, y is 5, y is 6, y is 7, y is 8, whatever value for y. So you give whatever value for y, what answer will you get for x? Because 0 into that y value will be 0. So x will be equal to minus 11 by 3. Now this equation has two variables x and y. Whatever be the value for y, whatever value y takes, any real value it takes, 0y is finally 0. So what will be the value of x? 3x plus 0 plus 11 is equal to 0. So 3x is equal to minus 11. X is equal to minus 11 by 3. Which means here, whatever be the value of y, the value of x is always minus 11 by 3. Minus 11. If y is 0, x is minus 11 by 3. If y is 1, minus 7 by 3. 2, minus 7 by 3. 3, minus 7 by 3. Whatever be the value of y, the value of x will be minus 7 by 3. See, I'll show you again. 3x plus 0y plus 11 is equal to 0. All right. Now I have to, or we have to understand why it has infinitely many solutions. Because whatever value you give for y takes any value, any value. When you solve, what value you will get for x? Any value you give for y. So 0 into that will become 0. So when you work for x, you will get 3x is equal to minus 7, x is equal to minus 7 by 3. So whatever be the value for y, x is always minus 11 by 3. Minus 11 by 3. Now the next, so we understood why it has infinitely many solutions. The next thing is how do you say it's a straight line in the Cartesian plane? Because when you have x and y values, you have to make use of the x and y axis. No, you need two axes. If it's only one value, number line is enough. Only one line is enough. If you have two values, then you need to show one line for x values, another line for y values. So you have to use the coordinate axis or the Cartesian plane. And in the Cartesian plane, when you plot this, any value, so we'll just say 0, 1, and 2. Okay, 0, 1, and 2. Where will you get minus 11 by 3, comma 0? Supposing this is minus 11 by 3. Okay. Supposing this is minus 11 by 3. Y is equal to 0, 1, 2. Y is minus, x is minus 7 by 3, minus 7 by 3, minus 7 by 3. Now we'll just say that this is only minus x. What are the points here? You get minus 11 by 3, comma 0, minus 11 by 3, comma 1, because x value first and then the y value, minus 7 by 3, comma 2. We'll have to plot these points. Now, supposing this is minus 11 by 3. Okay. So minus 11 by 3, comma 0. So it will be this one only. Then minus 7 by 3, comma 1. So that will be here. Then minus 7 by 3, comma 2 will be here. So when you join, this is the straight line that is represented by the equation 3x plus 0y plus 11 is equal to 0. This is the straight line that represents the equation 3x plus 0y plus 11 is equal to 0. So so what you have to remember is when a linear equation in one variable x is treated as a linear equation in two variables x and y, it'll have infinitely many solutions. And since it has infinitely many solutions, the geometrical representation of this equation will be a straight line in the Cartesian plane. Where did we start off? Linear expression. Understood that, all of you? Then linear equation. How many solutions does it have? Linear equation in one variable x? Only one solution. Only one solution. Sorry, Chandra, just a minute. Yeah, children. So what was it? So linear equation and one variable x, one solution. One solution means the geometric representation is a point in the a point on the number line, correct? A point on the number line. Then this equation can be treated as a linear equation in two variables x and y. Then it will have infinitely many solutions. Because in this case, whatever be the value of y, the value of x will always be minus 11 by 3. And when you take three such points and plot in the Cartesian plane, and if you connect it, you will get a straight line. So infinitely many solutions, geometric representation is a straight line on the Cartesian plane. And the straight line in the Cartesian plane can be only these possibilities. Either it will be the x-axis itself, or it will be the y-axis itself, or it will be a line parallel to the x-axis, or it will be a line parallel to the y-axis. Only one of these four cases is possible. That is, when we treat a linear equation in one variable x as a linear equation and two variables x and y, then only one of these is possible. The geometric representation is a straight line. That straight line may be the x-axis itself, or the y-axis itself, or it will be a line parallel to the x-axis, or it will be a line parallel to the y-axis. Now you saw, no, we got a line parallel to the y-axis. See here, we got a line parallel to the y-axis. So maybe you'll get a line parallel to the x-axis, sorry, y-axis on this side. You can get a line parallel to the y-axis to the left of the y-axis or to the right of the y-axis. Or you'll get a line parallel to the x-axis, above the x-axis or below the x-axis. So it will either be parallel to the x-axis, parallel to the y-axis, or it will be the x-axis itself or the y-axis itself. Oh my, I wanted you to make a note of this. Till here, have you written, children? All of us written till here? Okay, I cleared this by mistake. I'll write it again. Please continue. See, you should do write like this. Watch me. For any value of y, for any value of y, the value of x is always minus 11 by 3. Like this, you must write. You should fill the y value first. You take any value. You don't have to give 0 onto anything. Whatever you want, you can write. You can write like minus 5. You can write minus 5, 0, and some 3. Whatever be the value of y, the value of x will be minus 11 by 3. Correct? So write this. And then the geometric representation. So I'm just taking this one as minus 11 by 3. So minus 7 by 3. And supposing this is minus 5. So this is 1 point. This is 1 point. And supposing this is 3. Hello. All right, children. This is clear? He's always blushing. I don't know why. You're distracting yourself. You must remind yourself that you're in a class where you have come to learn something. And the mind can do only one thing at a time. If you're blushing, your mind is concentrated. Your concentration is there. So what I talk will just be some sound you're receiving, but you will not be able to comprehend that sound. So you should just, it's very normal for a student to behave like that. It's very normal. Your behavior is normal. Not a blunder to laugh. It's okay, but this is not the right place. So we should tell ourselves. Then you will not do it. Yeah, children. So this is about it. We'll just take a few more examples. What are you doing? I'm advising him, and you're doing something to make me laugh. Now he'll put that back to me. Ma'am, it's okay to laugh like that, ma'am, but this is not the place for you to do that. Online students, have you finished the slide?
Yes, ma'am.
Very good. Now look at the next one. Another example, children, for the same situation, another example. All right, supposing we have x, say like +7 is equal to 0. What is this? It is a linear equation in one variable x. So on solving, what do you get? X is equal to -7. If you treat it as a linear equation and one variable x, then its geometrical representation is a point on the number line. -1, -2, -3, -4, -5, -6, and -7. All right. -7, you can just show one more. So this one is x is equal to -7. Correct? You can just keep a point and you don't have to put the arrow and all that. You can just write x is equal to -7 on it. That's all. Just mark it like this and write x is equal to -7. All right. Now this is the case if it is treated as a linear equation, one variable x. Now two variables x and y. So then it will become x plus 0y plus 7 is equal to 0. Because the missing variable is y. So 0y. Now what will happen? Whatever be the value for y, anyways, it is 0y. That means what? 0 into anything, 0 into y. 0 into any y value will be 0 only. So on working this, what will you get? X is equal to -7. How much is 0y? 0. So when you work this equation, it will become x is equal to -7. That means x is always -7 for any value of y. For any value of y. So y is like, say, whatever value of y, -3, 1, 2. All right. Any value. For any value of y, now just plot this x-axis, y-axis, plot this -7, 3, -7, 3, somewhere here, -7, 1 here, -7, 2 here. So see, this is the line x plus 0y plus 7 is equal to 0. Correct? Done writing, children? Now we'll take y. We'll take in one variable y. Online student, done this one? Online students, use the emoji, raise your hand. Bhavishya, Swati, Niveda, Aniruddhan, Hari Pranav, Sahana, and Laksha. Are you there? Laksha. Okay. All right, children. Thank you. Yeah. Done writing this one, all of you? Okay. Yeah. Now consider another equation. It can be complicated. We are taking simple situations because we'll get only such situations. Now don't think now why she's not using root 3 and all that. She's taking examples where everything is simple. I'm taking examples which is needed for you. Okay. Yeah. So supposing say like 2x minus, or what was it earlier? Minus. Okay. So minus 5 is equal to 0. Consider this equation. Okay, consider this equation. So when you solve this, you get x is equal to 5 by 2 or 2.5, right? 2.5, correct? So if you treat it as an equation in one variable, then this is 2.5, correct? So this is x is equal to 2.5. Yes or no, children? It's a, yeah. Now if you treat this as an equation in two variables x and y, then it will be 2x plus 0y minus 5 is equal to 0. Then you should take a table like this and give any value for y, because 0 y, no? So 0 into any value of y will be 0. So give any value for y, minus 3, 0, 1, any value for y. Anyways, it will become 0. So what will be the value of x? 2x is equal to 5, x is equal to 5 by 2, 2.5. So you will get 2.5 everywhere. For x, it will always be 2.5. Now, when you plot this one in the Cartesian plane, 2.5 comma minus 3. So this is like 1, this is 2, this is 3. So 2.5 is here. 2.5 comma minus 3. Say this is minus 3. So 2.5 minus 3 is here. Then 2.5 0 is this one only. And then 2.1 1. 2.5 and 1 here. So I'm not connecting it properly, children. Please understand. So this is the line. So you can again see it's parallel to the y-axis. This line is parallel to the y-axis. And this is given by 2x plus 0y minus 5 is equal to 0. Understand? Right on? Done this, children? Okay. Online students, there's no response from your side.
Done,
Done?
ma'am.
Done,
Done.
ma'am.
Done, ma'am.
Done, ma'am.
All right, yeah, thank you. Now we'll just consider some equations with y variable, okay? Let's take y, or say like y minus 6 is equal to 0, and we'll take y plus 3 is equal to 0. Okay, so if you treat it as a linear equation, one variable y is equal to 6. So number line 1, 2, 3, 4, 5, 6. All right. So here when you solve, you get y is equal to minus 3. Correct? So number line 0, minus 1, minus 2, minus 3, minus 4. This is if treated as a linear equation and one variable y. Then only one solution, which is 6 and minus 3. And the solution is represented by a point on the number line, which you can see here. These are two different cases, children. I'm just doing it side by side. Two different cases there. Now we'll treat the same equations as equations in two variables x and y. Okay. So it will become 0x plus y minus 6 is equal to 0. And here, children, what will this become? 0x plus y plus 3 is equal to 0, correct? The variable x is absent. So we'll say 0x. The variable x is absent, so 0x. Okay, now put the table because there are two values, no, x and y. So you need to put a table. So here also. So here what is 0x? That means whatever be the value of x, 0x, no? So whatever be the value of x minus 1, 0, 1. Whatever be the value of x minus 2, 0, 2. Because 0x, no, so 0 into anything is 0 only. 0 into anything is 0. So whatever be the value for x, in this case, the value of y will be 6. Y will be 6 always for any value of x. In the second case also, whatever be the value of x, it will become 0. So y will always be minus 3. Y will always be minus 3. All right. Now, when you put this in the when you represent this in the Cartesian plane, minus 1 comma 6. Where's minus 1 and comma 6 here, right? Oh, sorry, not there. Minus 1 comma 6. Okay, so it will be here minus 1 comma 6. Then 0 comma 6. So this is 0 comma 6. And then 1 comma 6. 1 comma 6 here like this. This is 1, children. This is 0. This is the line given by 0y plus 0x plus y minus 6 is equal to 0. This is the y-axis. This is the x-axis. This is the x-axis. This is the y-axis. And this is that line. When we plot the points minus 1 comma 6, 0 comma 6, and 1 comma 6, we get 3 points which are collinear. Meaning you can connect them by the same straight line. And you see that the line is parallel to the x-axis. And finally, when you plot this one, x dash, y dash, minus 2, minus 3, minus 2, minus 2, minus 3. This is minus 3, okay? So minus 2, minus 3 is here. Minus 2 on the x-axis, minus 3 on the y-axis. Then 0, minus 3. 0 and minus 3 here, this one. And then 2, 2 and minus 3. 2 and minus 3 is here. So this is the line given by the equation 0x plus y plus 3 is equal to 0. So you can see that this line is parallel to the x-axis, but below it. Correct? So we saw all the 4 cases, not all the 4 cases. We have seen 4 cases where the lines are either parallel to the y-axis to the left, y-axis to the right, or the line is parallel to the x-axis above it, x-axis below it. Okay. Yeah, finish this. We are plotting, we're not just drawing a line, we are plotting it actually. Yes? Okay. Ready for the next one? Now, now supposing we have the equation x is equal to 0. It's a linear equation on one variable x. It's a linear equation, one variable x. So its representation on the number line will be this one only. This one only, x is equal to 0. Or the variable is y, If the variable is y, because when it's on the number line, the variable does not make any difference. Number line is only one axis. Whether the variable is a, b, c, d, everything is the same place. If the variable is q, that's only the q is equal to 0, that's the position. All right. Now, so when x is equal to 0 and y is equal to 0, when you treat these two equations as linear equations in one variable x or y, one variable x or one variable y, then what's the solution? 0 is a solution because x is equal to 0. 0 only is a solution. See, if you get x is equal to -7 is a solution. If you get x is equal to -7 is a solution. Now here x is equal to 0. 0 is a solution. Y is equal to 0. 0 is a solution. And how will you represent the solution on the number line? 0 at 0, right? The solution is 0. And because we are treating it as an equation and only one variable x or y, it's a point on the number line and you can see where it is represented. Now, if you treat the same thing as linear equation in two variables x and y, so it will be x plus 0y. X plus 0y is equal to 0. Or 0x plus y is equal to 0. Because there is x, so 0y. Here there is y, so 0x. Correct? Here there is x, so 0y. Here there is y, so 0x. All right. Now, since we have, so this is one variable x, this is two variables x and y. This is one variable y, this is two variables x and y. So let's again take a table and show the values of x and y. Now 0 y, no, so y is always 0. Y will always, sorry, whatever be the value, not y is always 0, sorry. Whatever be the value for y, 0y is 0. So you can give any value for y. You give any value for y, it's going to become 0 into y, 0 only. So whatever be the value for x, whatever be the value for x, y will be 0. You got confused now? You give any value for x. See, okay. Now you give any value for what will be 0. What's the value of 0y? What's the value of 0y? 0. So that means whatever value you give for y. Oh my, I went wrong, sir. Yes. Sorry. I went wrong. A student corrected me here. Yeah. 0 into y. That means whatever be the value for y, x will be 0. Whatever be the value for y, 0 y, no. So whatever be the value for y, if you put y as 1, y as -2, y as 3, whatever be the value for y, 0 into that value of y will become 0. And when you work, you will get x is 0. You will get x is 0. So x is always 0 for any value of y. Y can take any value. Y can take any value. You give any value for y, 0 into that any value will be 0. And so x is always 0 for different values of y. On the other hand, here, you give any value for x. Any value for x. So x can take any value. So x can be -2, x can be 0, x can be 3. X can take any value. And 0 into that any value is 0. So y is always 0, no? Y will always be 0. Y is always 0. Y is always 0. Now plot this. Plot this one. Zero, comma -2. 0 and -2 here. 0, 1. 0 and 1 here. 0 and 3 here. So see here, it's a y-axis itself. It's a y-axis itself. -2, 0. 0, 0. 3, 0. The x-axis itself. You don't have to connect at all. It's already on the x-axis, which is the x-axis itself. So y is equal to 0. y is equal to 0 is the equation of the x-axis, and x is equal to 0 is the equation of the y-axis. If you treat x is equal to 0, y is equal to 0 as a linear equation and only one variable x or y, then it is a point on the number line. If you treat x is equal to 0 or y is equal to 0 as a linear equation and only one variable x or y, then it has only one solution. And the solution is 0 itself. X is equal to 0, y is equal to 0. The solution is 0 itself. It has only one solution and the solution is 0. And its geometrical representation is 0 on the number line. Now, these equations, x is equal to 0 and y is equal to 0. If you treat them as equations in two variables, x and y, then they'll have infinitely many solutions. So for that, you should put the table and show the xy values. What is along with 0? 0, y in the first case. In the first case here, this one. Here, what is it with meaning what is with 0, 0, y, right? So whatever be the value for y, 0 and y, 0. So whatever be the value for y, 0 and y, 0. So x will always be 0. So that's why any value you give for y, x is 0. Here, whatever value you give for x, y will be 0. And when you plot those points, you will get the x-axis or the y-axis itself. So x is equal to 0 is the equation of the y-axis. Y is equal to 0 is the equation of the x-axis. Another way of remembering that is, it's not difficult. Supposing you get confused in the exam, you're not sure. You just mark the point. What will be the address of this point? 1, 0. What will be the address of this point? -1, 0. What will be the address of this point? Maybe -3, 0. So what is 0 always? What is 0 always? The x coordinate or y coordinate? Ah. No. See, okay, fine. I think I went very fast. See, I said, mark some points, mark any point. Mark a few points on the x-axis. So I have marked 1, 0, -1, 0, and -3, 0. In the address here, is the x coordinate always 0 or y coordinate always 0? Y coordinate is always 0. So y is equal to 0, right? That is the equation of the x-axis. Now, take some points on the y-axis. Maybe this is 0, 5. This one is some 0, -5. This is 0, 0. But which is always 0? X is always 0. So x is equal to 0 is the equation of the y-axis. X is equal to 0 is the equation of the y-axis because on the y-axis, x is always 0. That's why. And y is equal to 0 is the equation of the x-axis because on the x-axis, y is always 0. That's why y is equal to 0 is the equation of the x-axis. So there are 6 cases in all. So this is where we started. When we take up a linear equation on one variable x or in one variable y, and we want to treat it. That is, in the equation, there is only one variable x or one variable y. But you want to treat it as an equation in two variables x and y. So if x is not there, you will write 0x. If y is not there, you will write 0y. Then it becomes a linear equation in two variables x and y. Then it no longer has one solution. It has many solutions. So then you should take a table and write the xy values. When you plot these values, you will see one of these 6 things. You will see that the line is the x-axis itself, or the line is the y-axis itself, or the line is parallel to the x-axis. 1 minute. So when you treat a linear equation, one variable x, or when you treat a linear equation in one variable x or in one variable y as a linear equation in two variables x and y, then one of these 6 things only is possible when it comes to the geometric representation. Either the geometric representation is the x-axis itself. We know that the geometric representation is a straight line. That straight line is the x-axis itself, or the straight line is the y-axis itself, or the straight line is parallel to the x-axis above it, or the straight line is parallel to the x-axis below it, or the straight line is parallel to the y-axis to the left side, or the straight line is parallel to the y-axis to the left side. So above, below, parallel to the x-axis, left, right, parallel to the y-axis, or it is the x-axis itself or the y-axis itself. These are the 6 possibilities when you treat a linear equation in one variable x as a linear equation in two variables x and y. Only one of these 6 things will happen. That's what we saw from the beginning with examples. Okay, that's what we saw with examples. All right, children. Now, which part should you write down? I don't know. This one finished?
This
This is over, is it? Then this one? Okay, write down this. Done, children? Okay. Now, moving to a linear equation in two variables x and y. Okay. Ax plus by plus c is equal to 0 is the, write down, standard form, is the standard form of a linear equation in two variables x and y, where a, b, and c are real numbers and a not equal to 0. Sorry, a and b not 0 at the same time. This can be better written like this, children. You can write this condition: a square plus b square is not 0. A, B, C are real numbers. and a squared plus b squared is not equal to 0. That means a and b are not 0 at the same time. We've just understood a lot. So I'll explain this a square plus b square not equal to 0 on a different day. Like when you are working more relaxed, then if I tell you this, you can receive better. So just for now, you just remember as a condition. So ax உங்க 3 பேரையும் பார்த்தா kindergarten நடத்துற மாதிரி தான் இருக்கு. Divatsan is like, நான் என்ன பண்ணேன்? Why you including me? Yeah, it's not him actually. I wonder how you were when you were in kindergarten. My God. Okay, so ax plus by plus c is equal to 0. All right. So ax plus by plus c is equal to 0 is a standard form of a linear equation in two variables x and y. So you can see the two variables x and y here. You can see x here and y here already in the equation. So ax plus by plus c is equal to 0 is a standard form of a linear equation on two variables x and y where a, b, c are real numbers and a squared plus b squared should not be equal to 0. That means a and b are not both 0 at the same time. If a is 0, b should not be 0. If b is 0, a should not be 0. Because if both a and b are 0 at the same time, then it will become 0x, 0y. Then there's no x, no y. Yeah, that's the reason. So either a is 0, then b should not be 0. Or if b is 0, a should not be 0. If both a and b are 0, what are a and b? The coefficients of x and y. Then if it is 0x and 0y, then there is no x and y. So there's only the constant c. Then how can you say it's linear? Okay, so before that I should have written this one. Ax plus by plus c is equal to 0. Oh, sorry. Ax plus by plus c is a standard form. What is this? Is a standard form? Standard form of a linear expression. Yeah, online students. What should I write? Ax plus by plus c is a standard form of a linear expression. Linear expression in two variables. X and y, where a, b, c are real numbers and a square plus b square is not equal to 0. I should have written this part first. I forgot to write. So this one actually comes first and then this one. This one is first. But now don't rub and write anything. This one is the first part. This is the second part. Warm, cool, warmer. You can just mark it the way I've marked, children, so that because we should talk about the expression first and then the equation. First, the expression ax plus by plus c. Then when you equate it to 0, it's called a linear equation. Just forgot to write that. Yeah, so I have prepared a case study based. I've compiled case study based questions. I think I've collected about 9 or 8 to 9 questions. Case study based questions from the last chapter, coordinate geometry. So before you come to the next class on Friday, try to at least read the questions, understand what it is, and if you can answer it, well and good. We'll discuss answers in the class on Friday. So take a Xerox. I'll share the Word file. I'll share the Word file. Take a Xerox, and you can answer it in the paper itself. Like this, see, when you take, I don't think you would make a back-to-back Xerox. No, so mostly it is like only one side you take a Xerox. So the side behind you can just do some working and use a pencil and fill it in the paper itself. Don't write the question again in your notebook and all that. Don't do that. I'll share the Word file. Take a Xerox and use a pencil and work it in the paper itself. So try to finish it. On the 8 question, at least 3 to 4, as much as possible, try to complete and come to the next class. Yeah, is this over? Yeah. Online students completed?
Yes, ma'am.
Completed, ma'am.
Okay. Yeah. So now coming to the solution part. Now this one should be written first. I told you, no, this is first and this is second. So I'm continuing with the second one. The second part I'm continuing. This linear expression part is the first one, then the linear equation part. So I'm now continuing with that. You just continue writing, that's all. I'm just telling you. So now coming to the solution and geometric representation. That's the order we are learning today. So now we saw ax plus by plus c is equal to 0 is a standard form of a linear equation in two variables x and y. Now, how many solutions it has? How many solutions it has? And what is the geometric representation? Geometric meaning the graphical representation. Okay. So, linear equation in two variables x and y has infinitely many solutions. Has infinitely many solutions. A linear equation in two variables x and y has infinitely many solutions, because if you give one, if you say x is 1, then you will maybe get y is 3. If you put x is 2, you will get some other value for y. If you put x is minus 1, you will get a different value for y. So every time you give a particular value for x, you will get a different value for y. All right. That's why we say infinitely many solutions. A linear equation in two variables x and y. What is that? Ax plus by plus c is equal to 0. Now, when you give a specific value for x, now look at this example. Supposing we have 2x minus 3y plus 7 is equal to 0. Okay. Now, if you give x is equal to 2, you'll get some value for y, no? When you solve this, you'll get some value for y. Yes or no? Now, if you put x is 3, you'll get some other value for y. If you put x as 0, some other value for y. So every time you give a value for x, you get a different value for y. Or if you give different values for y, you will get different values for x. That's why we say a linear equation in two variables x and y has infinitely many solutions. Because for a set of values for x, you'll get a set of values for y. And for some set of values for y, you'll get a set of values for x. So you can keep doing this. You can give as many, you can keep giving values for x and you'll keep getting the corresponding values for y, right? So it's endless. So that's why we say it has infinitely many solutions. A linear equation in two variables x and y has infinitely many solutions. And now it's geometric representation. Okay. Geometrically, it is represented by a straight line in the Cartesian plane. Geometrically, it is represented by a straight line. By a straight line in the Cartesian plane. Fine, children. This is over. Okay. Now let's just let's see how fast we can sum it up. So we started here. We started here, right? What is this? Linear expression. Online students, you can also participate, please. What is this? Online students, ax plus b, linear expression in one variable x. Linear expression in one variable x. When you equate this to 0, it's called a linear equation in one variable x. Correct. Linear equation in one variable x. Now, how many solutions will this have?
Only one solution.
Only one solution. Only one solution. Because just take an example. There's nothing to get confused. Supposing ax plus b, no? So some 3x minus 7. There's only one variable. Now don't write 3x minus 7y. There's only one variable. So say like 3x minus 7 is equal to 0. How many solutions you'll get? X is equal to 7 by 3. That's all. Only one answer you will get. So only one solution. Ax plus b is equal to 0. Only one solution. Now after solution, the geometric representation. What is it? Geometric representation is a point on the number line. Correct? This is about linear equation in one variable x. Now the same thing, the same equation in one variable x can be treated as a linear equation in two variables x and y. Correct? Correct? Or supposing there was the variable y here. Supposing here it was ay plus b is equal to 0. That is the variable is y. Ay plus b is equal to 0 is a standard form of a linear equation in one variable y. Ay plus b is equal to 0 is a standard form of a linear equation in one variable y. If you write ap plus b is equal to 0, it's a standard form of a linear equation in one variable p. That's all it is. So if it is ay plus b is equal to 0, this also will have only one solution because only one variable y, so only one solution. And the solution can be represented by a point on the number line. But the same thing can be treated as 0x plus ay plus b is equal to 0. Because there is y, there is no x, so 0x. Here there is x, there's no y, so 0y. So here what we understood is, then it is a straight line in the Cartesian plane. If you treat it as two variables, whenever you have two variables, it's a straight line, children. When there are two variables, it will be a straight line. Because when you give a set of values for x, you will get something for y. When you give values for y, you will get for something for x. You're not going to get one answer. One answer you will get only if there's one variable. If there's more than one variable, you will get many answers, many solutions, infinitely many solutions. And these solutions, when you plot them in the Cartesian plane, you can connect them by straight. There'll be collinear points. The points when you plot, no, they will be collinear. If it is linear, it will be collinear. If it is quadratic, they'll not be collinear. You will get U kind of stuff. So if it is quadratic, if it is ax squared plus bx plus c, if it's like this, then when you make the, like table and plot, you will get points like this. That'll not be, if it's quadratic, it will not be a straight line. If it's quadratic, it will not be a straight line. It's a straight line only if it is linear, only when the power of x and y is 1. So when you plot the points, they'll be collinear. You will be able to connect them by the same straight line. So here you understood when you give for this case, in this case, you give any value for y, any value for y. In this case, you give any value for x. You give any value for x. Okay, so whatever be the value for x, you will get a specific. So sorry, here, whatever be the value for y, you will get one specific value for x. Here, whatever value you give for x, you will get one particular value for y. So here only I said 6 cases are possible. When you plot the points, either the points will be the x-axis, meaning the points will be on the x-axis itself or on the y-axis itself, or the lines. After plotting the points, when you join them and you get the line will be parallel to the x-axis, above it, below it, or it will be parallel to the y-axis, to the left of it or right of it. So this is what we saw in one variable x. Now two variables x and y, ax plus by plus c. This is the standard form of a linear expression or a linear polynomial in two variables x and y. Ax plus by plus c is ax plus by plus c is a standard form of a linear polynomial. Linear because x and y power is 1, x to the power 1, y to the power 1. So linear polynomial in two variables x and y. Conditions a, b, c are real numbers, but a square plus b square should not be 0, which means both a and b should not be 0 at the same time. If a is 0, b should not be 0. If b is 0, a should not be 0. Because if both of them are 0, then it will be 0x and 0y, which means there is no x or no y. Then it is not linear, then no variables at all. So here the condition is a, b, c are real numbers, a square plus b square not equal to 0. If you equate this to 0, linear equation in two variables x and y. Solution, infinitely many solutions. Geometric representation, straight line in the Cartesian plane. This straight line can be anyways. This can be like this, whatever, like this. This one, it can be parallel also. But this one can be of any type. That one variable x, when you treat it as an equation in two variables x and y, that will be parallel. If it has only one variable x or y, but you treat it as an equation in two variables x and y, that will be parallel line, or it will be, the x-axis or the y-axis itself. These can be any lines. The line can be any ways like this. All right. Okay. Now look at this question, children. Another 10 minutes. Okay. So see here, solve that equation. Okay, you can see an equation there. X by 3 plus 2 is equal to 2x minus 3. How many variables are there? Only one variable. So it's easy, you can solve and find the value for x. There's only one variable. You can solve it and find the value for x. Okay. Solve that equation is the question. Solve that and represent the solution or solutions. Okay, whatever. If you're getting one solution, many solutions, that the question will not say. So represent the solution or the solutions in the Cartesian plane and on the number line. We understood that the solution or solutions can be geometrically represented, right? Either it's a point on the number line or straight line in the Cartesian plane. So that's the question. So understand the question, solve this equation and find the solution or solutions and represent that solution in the Cartesian plane and on the number line. Now you don't work it now, you can just have a look. Here I've solved the equation. So you can see here I've written the equation. See, you can transpose, you solve however you want. I'll tell you how I've solved here. So I've taken the LCM. You can even transpose. See what you have. X by 3 plus 2 is equal to 2x minus 3. No, you can write x by 3 minus 2x, correct, is equal to 3. No, minus 3 minus 2, correct? You can even take it to the other side. X by 3 plus 2 is equal to 2x minus 3. You can solve it however you want. You can even transpose it like this. Minus 3 minus 2. Take the LCM. X minus 6x is equal to minus 5. Cross multiply. Minus 15. X is equal to 3. Here also you've got x is equal to 3. So you work however you want. You can. Okay, so you can solve it however you want. So the solution is x is equal to 3. The equation has only one variable x. The equation is only one variable x. And so we got only one value for x because one variable meaning only one solution. Only if you have two variables, you can have infinitely many solutions. Okay, x is equal to 3 is a solution. So on the number line, see here, I'll just tell you on the number line. On the number line, x is equal to 3. See, the question is represent the solution. This is the solution. X is equal to 3 is a solution. Should represent it on the number line. So see here, draw the number line and this one is x is equal to 3. Correct? Okay, that's over. One part we have answered. Now the second part is to represent the same solution, x is equal to 3. Same thing in the Cartesian plane. In the Cartesian plane. So for that you should see, to represent it in the Cartesian plane, you should treat it as a linear equation in two variables x and y. If one variable x is only one solution, and that one solution is a point on the number line. If you want to represent the solution in the Cartesian plane, then Cartesian plane has x-axis and y-axis. So there should be x value and y value. But there's only x here. That means you should treat the equation as a linear equation in two variables x and y. In two variables x and y. So x is equal to 3 is written as, you can see here, x is equal to 3 as a linear equation and two variables x and y is x plus 0y minus 3 is equal to 0. Minus 3 because when you take this to this side, this is standard form. If you take this here, if you take this one here, it will be x minus 3 is equal to 0, right? If you take this one here, it will be x minus 3 is equal to 0. So in two variables, it will be x plus 0y minus 3 is equal to 0. See, children, this equation is nothing but x is equal to 3. That is what is given like this. That equation is nothing but x is equal to 3. That's what is there. Now, in one variable x, this is the solution. This is the geometric representation. In two variables x and y, x is equal to 3 means x minus 3 is equal to 0. Correct? There we have the variable x, we don't have y. So how will you write that? Plus 0y. So see here, x plus 0y. Minus 3 is equal to 0. This is how it is when you treat it as an equation in two variables x and y. Now, what does this mean? X is always 3 for any real value that I told you, give any value for y. Give any value for y. So whatever be the value for y, for any value of y, x is always 3. You can check it yourself. See, you can just do it. Now, supposing y is minus 1. What is 0 into minus 1? 0. So you'll get x is equal to 3. Then you give a different value for y. Y is minus 2. You keep changing the values of y, children, and you solve for x. You will get x is 3 only. You have the equation right there in front of you. You have it here. You give any value for y, and you find the value of x. For any value of y, you will see that x is always 3. So that's what it is. So you don't have to show that working at all. X is always 3 for any value of y. Please understand that this will always be 0. That means x minus 3 is equal to 0. X is equal to 3 only. You get always whatever value you give for y. So take any random value for y. X will always be 3. Now plot this. Plot this one. You can see it here. This one is the answer for this one. Okay. This one is the answer for this one. This is over. Number line, this is the answer. This is over. So now how do you do this? 3 minus 2. Where is 3 minus 2? 3 and minus 2 here. 3, 0 here. 3, 1. 3, 1 here. Join. You get the straight line. Correct? So that is the equation. X, you can write x is equal to 3, or you can write x plus 0, y minus 3 is equal to 0. Anything you can write, but you should write the equation. That line is given by an equation. You should write that equation. You can write x is equal to 3, or you can write x plus 0, y minus 3 is equal to 0, whatever. So this is the representation. So when you treat it as an equation in two variables x and y, it's a straight line on the Cartesian plane. And you can see that the straight line is parallel to the y-axis and to the right of the it's parallel to the y-axis. It's parallel to the y-axis to the right of the y-axis, correct? So sometimes you'll be given only the statements like this. You should be able to construct the equation. Now I'll tell you for this. I'll tell you should now construct the equation. The question is construct the equation. The line is parallel to the y-axis at a distance of 3 units to the right of it. See this line. This line is parallel to the y-axis at a distance of 3 units to the right of the y-axis. Yes or no? So then it will be x is equal to 3. You should be able to write. We'll do that in the next class. So given the description of the line, you should be able to write its equation. Given the description of the line. So how will the description be? I'm telling you again. The line is parallel to the y-axis. This one, I'm saying this situation. The line is parallel to the y-axis at a distance of, and it is at a distance, the line is at a distance of 3 units from the y-axis to the right of it. So it's parallel to the y-axis. The distance is 3 units. 3 units on the left side or right side? Right side, 3 units. If this description is given, you should be able to write the equation. And to write the equation is very simple because if it is parallel to the y-axis, it will be x is equal to something. If it's parallel to the x-axis, then it will be y is equal to something. If now in this case, it's parallel to the y-axis. So the equation will be x is equal to something. And what will that x is equal to be? The distance is 3 units. If it is right side, plus 3. If it's left side, minus 3. So either the answer is x is equal to plus 3 or x is equal to minus 3. See, you should just look out for the keywords. Parallel to which axis, x or y? Supposing y axis, parallel to the y axis, then you should be ready, x is equal to. Then read the next thing. What is the distance? 3 units. So the number is 3. Now next sign, plus minus sign. Is it on the right side or left side? Right side, then plus 3. That's all. So these are 3 things you should look out for. It's parallel to x-axis or y-axis. That's the first thing. Then the distance. Then is it above, below, or left, right? Okay, I think let me finish it now so that it will be complete. 1 minute. So if I say parallel to x-axis, then you will be ready with y is equal to. Okay, parallel to x-axis. So this is the x-axis. Parallel to the x-axis can be like this here, or it can be like this here. Correct? This is the x-axis. This is the y-axis. See, parallel to the x-axis meaning can be like above it or below it. Correct? Parallel to the x-axis can be above the x-axis or below the x-axis. If it's above, positive, below, negative. With above, positive, because here you have positive values, no? If it's below, negative. Okay, so now look out for the words. Parallel to the x-axis. So you write y is equal to. At a distance of 6 units. At a distance of 6 units. So you write y is equal to 6. Then you should look out for the word above or below. If it is above, you'll write y is equal to plus 6. If it's above, you'll write y is equal to plus 6. If it's below, you'll write y is equal to minus 6. So the equation in the standard form will be y minus 6 is equal to 0. Here the equation in the standard form will be y plus 6 is equal to 0. This is the equation in the standard form. That is everything on one side equal to 0. So again, if I say it's parallel to y-axis, if I say, then you will be ready with x is equal to. Then you look out for the distance. What is the distance? If I say the distance is 5 units, so you'll be ready with x is equal to 5. Then it's parallel to the y-axis, no? So it will be like this or like this. So if it is left, it will be negative. If it's right, it will be positive. So if you find the word left, then you should put x is equal to minus this left. You should write x is equal to minus 5. If it is right, then you must write x is equal to plus 5. If it's this one, then it will be the standard form x plus 5 is equal to 0. If it is like this, you will write x minus 5 is equal to 0. So this is a very common question, giving the description of the line and expecting you to construct the linear equation without making the graph. Should not make the graph. Just by reading the description, you should be able to judge the equation that line is given by. So these are the keywords. Parallel to which axis? Distance. Then above, below, left, right. Left is negative, right is positive. Above is left is negative, right is positive. Above is positive, below is negative. Correct? Right means positive. Above means positive. Left side means negative. Below also means negative. Parallel to the x-axis means you should be ready with y is equal to. Parallel to the y-axis meaning you should be ready with, what did I say earlier? I forgot. If it's parallel to the x-axis, y is equal to. If it's parallel to the y-axis, then x is equal to. Then the distance will be given to you. So this is how you construct the equations. All right. Online students, use the emoji, raise your hand. Bhavishya, Pranav Rajan. No, not Pranav Rajan. What are you? Hari Pranav, sorry. Hari Pranav, Aniruddhan is not there. Niveda, Swati, Sahana, Laksha is there, but yeah. Okay. All right, children. All right, students. Online students, so that's it for today's session. Thank you so much. I'll just stop the recording and I have to share something with you. Yes.